Welcome back to week 4, and we are going to continue in video 4 discussing some of these internal processes and more specifically how these plate boundaries and plate tectonics are related to features on the seafloor, coastlines, and some of the materials that we get. So divergent boundaries, and this is where we have oceanic crust created at those mid-ocean ridges, the high point on the ocean floor, such as the middle of the Atlantic Ocean. We see fracture zones. We also see seamounts where we end up connecting the oceanic crust to the continental crust. That's where we see the drop-off right at the edge of the continental shelf. So we see that continental rise, steep section, continental slope. And where we have plates colliding, a lot of times we create uplift and volcanic eruptions. This uplift accelerates erosion, deposition of these sediments and sedimentary rocks. So where we have convergent plate boundaries, where the crust is moving up or down, active coastlines, where we have emergent and submergent features. So again, those active versus passive coastlines, I just talked about active, where you have a boundary, two plates colliding, pulling apart, sliding past one another, such as the Cascade Range, San Andreas Fault. An example of a passive coastline would be the East Coast, where we don't have any tectonics happening right on the edge of that continent. Yes, we have some happening out in the middle of the ocean, but that's too far away from the actual coast. So the activity has to be happening right on that edge of the continent for it to be considered active. And just to review a little bit, active, we have subduction, divergence, transform boundary happening. Here's examples of active coastlines here, and this would be an example of a passive coastline. No plate boundary, no subduction, no earthquake activity, just very calm environment. And some of the features that we see on those on those active boundaries, we see headlands, we see sea stacks, some sandy beaches in some locations. We see terraces that develop due to the crust uplifting out of the oceans. So we tend to have a more rocky coastline where we have solid rock exposed to erosion. And then that solid rock depends on what type it is, depends upon the actual geology of that location. And then we have those eroding away, producing the different types of sediments that we discussed back in week 2. So passive boundaries, this is where we get lots of beaches built up. You see these wide sandy beaches, barrier islands, hooks, spits, so on and so forth, in these passive margins like the east coast of the United States. So this is more erosional surface, so we don't have as many of those rocky coastlines or headlands. We see mostly just sand because we have longshore drift dominating the geologic process at this location, moving that sand from one place to another. So again, zooming in on the Pacific Northwest, here we've got the convergent boundary right off the coast. Oregon here, Washington up here, divergent plate boundary, active plate margin, lots of rocky coastlines, rocky headlands. If we look at the seafloor features here in the next picture, if I remove those, kind of change the orientation and remove those boundaries, you can see where the volcanoes are in the ocean floor at that divergent boundary, where our fracture zone is located. So here you can see that nice ridge that develops on the ocean floor, the flat abyssal plain, and then where those two different crusts are combining, continental slope and rise, and then the continental shelf on the very edge here, and then the volcanoes produced from subduction occurring right about along this boundary between our continent and oceanic crust. So kind of review things a little bit. Hopefully you're now familiar with the theory of plate tectonics. You could describe it to me. You could also list the evidence that exists to support this theory. And then you should be able to identify the different types of plate boundaries, what's happening at each, how motion is occurring at each of those locations, and then some features related to tectonics on the seafloor and the coastline, and where we see sand, where we see solid rock. Here's just a cool picture of a vessel that was used to actually drill into the ocean crust and collect samples from the ocean floor to tell us a little bit about what's happening down there. So I will sign off, and we will see you in lab.